Hi class. So we're gonna continue with the next lesson. So here we're gonna show you guys an example of a multi-layer perceptron model. The perceptron model is one of the first deep learning algorithms created for machine learning. And so in this case, we're gonna use a multi-layer perceptron. So remember from the PowerPoint that a perceptron deep learning algorithm or machine learning is very similar, or we try to simulate what a neuron network in your brain. So we're trying to replicate that idea, that concept, and the way it does is the information is passed through a current of positive and negative charge through your neurons. And but in order to be able to simulate that through a computer science, what we do is we create these nodes, and these nodes are linked through each other. Now the first set of nodes, that is your input nodes, we call it the input layer. The second layer of neurons are called your inner layers, and sometimes you can have one inner layer, two inner layers, three, four, four, five. It doesn't really matter how many you have, right? It all depends. That's something that you can change or fix. Now, the number of layers, or sorry, the number of nodes per layer can also be changed, and that also depends on the on you changing it so that it provides a better fit. Now, the last layer is what we call the output layer. So the input layer and the output layer cannot be changed. Those are fixed. Those are determined by the input value information that you're given, by the number of for the number of they're called features. Sorry, features, and so the number of features is going to determine how many input nodes you're going to have. The output will also be determined by the number of classifications that you can have, the possible options that you can have. So that is a little bit of a short review of what the deep learning is. Remember, it's a representation of the neural network. So we saw previously how we want to build a multi-layer perceptron model with the full session in TensorFlow. Unfortunately, this was an extremely involved process. However, the developer has created estimators that have easier to use the flow. It's much easier to use, but you sacrifice some level of customization of your model. Let's go ahead and explore it. So we could do this manually, like more detail, like we can build it from scratch. But that would be very, very hard. So my Python already has provided with many options for models of deep learning. There's a ton of different options. And so what we're gonna do here today, we're gonna go over one of those options just to give you guys a taste of this deep learning. But this it's a whole field in computer science. You can take multiple classes and still not be able to cover the whole thing, especially in graduate level courses. So what we're gonna do now is first we're gonna grab the information from the data file. So first we're gonna import the pandas as PD. Remember, this is just to give you a data frame. Then we're gonna create our data frame from reading from the CSV file of iris. So we need to extract that information from here. So I don't have it. Let me make sure that I get it. Okay, so we have it right here. You can just click upload and you can upload it there. Now I'm gonna copy the path. Well, I don't need to copy the path. I think this should be able to read it because we're in the same folder. Okay, so now what we're gonna do is I'm gonna show you guys the head, the first five input values of this data frame now that we grabbed from the iris CSV file. So, oops. Sorry, I needed to run those first. There you go. So this is talking about this information from this CSV file is talking about different types of petals on a flower. So we have the petal length, the petal width, the petal length, the sepal length, the sepal width, the petal length, the petal width, and then the target value. This is going to determine if it is of a specific type of petal. A flower. So let's define the columns of our data frame. So we're gonna go sepal length, sepal width, petal Okay, let's make sure this is running. So we're defining our columns, and then what we're gonna do here is we're gonna assign a value to our uh train to our we're gonna separate our columns that are going to be for our input versus the ones that are going to be for our target. So when we define our X, we're gonna define a subsection of our total data. So we don't want to include the target data. So we're gonna drop that. Now we're not gonna drop it permanently. We're just saying that we're gonna exclude it. We're gonna make a copy of it and save it into our X. Now we're gonna in our Y, we're gonna define the target and we're gonna turn it into an integer values. Then we're gonna split the data just the way we did it before from sklearn dot model under selection import train underscore test split. That's just to be able to use that tool that allows us to be able to separate our data for a train and for a test. Usually we do a 70% or 80% training and the rest testing. Sometimes we can actually create a validation. So we have talked about creating a type of validation. For this one, we're not gonna create a validation. We're just gonna separate the train test input values and then our target. We're gonna pass in the X, the Y, so those are gonna be the data we're gonna split. The size for the test will be 0.3. And now what we're gonna do is we're gonna import our tools from the TensorFlow. So TensorFlow provides tools for deep learning. We're going to again see what kind of columns do we have. Just to double check, we can always check what are the columns, right? We have the sepal length, the sepal width, petal length, petal width, and then the types are going to be object. And then we're going to have a feature of the columns. And what we want to do here is we want to add to our list of columns so what we wanted to do is we want to turn the values in our data frame into integer values. So we need to go through every single element, so every single column from our input and turn it into integer values. So that's what we're going to be doing here. Something wrong there. Did I not define? Oops, I didn't run that one. Now we can run this one. Oops. Numeric. Oops, I put a capital instead of a lowercase. Yeah, so the problem was that I put a capital there instead of a lowercase. So remember, just put a lowercase. Now let's check our list that we just created. And you can see here that we have created a list, and we have, this is one of our values. This is another value. So we created a numeric column where the key is the petal length. This is the shape. It's going to be a one-dimensional. Default value is none. The data type will be a float. Normalizing none. Because we have 4 columns. And then now what we're going to do is now what we're going to do is we're going to use this method. Well, it's a function that is going to allow us to be able to grab a section of the data, subsections of the data, and is going to allow us to shuffle that data and and then later on take a different portion of that data. So it's like we're creating multiple scenarios or multiple training scenarios with the same data but choosing a different section of it, so that we can create a little more complete training instead of being a little bit too instead of feeding it too much. Like, we don't want to fit the data or the model training too much. So instead we want to grab random data within the data section and be able to train the data with that different combinations of data. So let me show you. So right now we're going to call this input function. So this is what the name of the function that we're going to create. So we're going to use a TensorFlow compat.v1 version 1 estimator dot inputs dot pandas dot underscore, sorry, input underscore fn. So we're going to choose our x value come from the x train, our y value, which is our target, coming from the y train. So again, what we're doing is we're choosing a subsection of it. Now, the batch size is how big do we want this section to be. So we're saying we're going to take 10 size of elements on per batch, and then we're going to have another parameter which is called the epochs. How many times do we want to repeat this process of grabbing or separating the data into sections of 10? So this is saying we're going to do it 5 times. Now the next will be to shuffle the data so that we get a little more distributed data. That's a Y train. What is it called? Y train. Y train. We're gonna run everything else. All right, so that worked. So now what we're gonna do is we're gonna excuse me. We're gonna create our model that we're gonna train. So from the TensorFlow, we're gonna use this estimator. So we're gonna use this estimator to train our data. We have this deep neural network classifier. So this is going to be representing our model. This is going to be the representation of our layers. Oops, sorry, 20. And classes equals 3. So practically what we're doing here, we're creating this model. This is where we're actually creating, defining our model. We're saying from the TF estimator, we're gonna use a deep neural network classifier, that's like the model, with the hidden units of dimensions for our hidden layers will be 10, 20, and 10. How to classify 3 different classes. Our feature columns will be represented by the feature columns that we defined previously. And then we want to train the model. That train, so we're going to train it, the model, with the input value that we created. So our input value will be determined by the input function that we defined previously. So this is going to provide the data to our training while we're training it. So remember, we're saying that here from our input function will be coming from the input function that we define up here. Remember that we said that the input function would be grabbing from the train, X train and the Y train with a batch size of 10. So each section of the data will be a size 10. Epochs 5 means that we're going to repeat this 5 times. And then now we're going to run this, see if this works. Oops, classifier. And then what we're going to do is, so what we're going to do is we're going to use the predict method from the classifier model to create a prediction from the X test. So now that we have trained our model, now we can make predictions with the test data. So practically, we're going to do the same thing that we did before. So practically this, we're going to use this part right here. But this is, we're going to call this a prediction. And it's going to be a, well, not this one. I don't want this one, sorry. It was coming from this, I'm sorry. So it's going to be from the TensorFlow version 1 estimator inputs pamda inputs value. So what we're going to do is we're going to pass in, instead of the X train, we're going to pass in the X test. The batch size would be the length of the test. So the batch size would be the length of the test. We're going to shuffle false. And then we're going to make our predictions. Note predictions equals a list of classifier dot predict, and we're gonna get it from the input fn function predictions. So again, we define this. This is going to, again, graph is going to generate a section of data. It's going to create a section of data from the X test, and we're going to get a size of the size of the test. And what we're going to do is we're going to use that data to make a prediction. And we're going to put the prediction inside a list. And now that we have our predictions, the predictions are here in node predictions. Now let's see what our node predictions would be. So you can see here, logits, we're gonna have an array, the probabilities, the class IDs, the classes, all class IDs, and all classes. So now what we're gonna do, we're gonna make up final predictions. And I don't want to make it as long. Equals to an empty. And we're gonna we're gonna iterate through the node of predictions that we just generated before. And what we want to do is we want to make a prediction for, we want to add a prediction per column. Okay. Class IDs. Oops, lowercase. And so now what we're going to do is we're going to work on creating a confusion matrix. So from the sklearn.matrix, we're going to import the classification report confusion matrix. We're going to print our confusion matrix y test final. So we're going to compare our predictions with the final predictions. And we're going to see what we get. Every time it's going to change. And then finally, we're going to make our prediction classifications. Classification report y test final predictions. So we're gonna use all the different ways of making a measurement for our classifications. So prediction. So we have the prediction, the recall, the F1 score, and we can see our predictions here. So we have 3 classifications that we had 0, 1, 2. We were able to have a prediction for each one. So depending on what we have, it's gonna make a prediction according to that. So in this case, this is saying that for the 1 classification, it had a prediction of 33, a 1 for the recall, and a 50% on the F1 score, where the other ones had 0. Okay. But anyways, so we'll stop there. Again, this is just a little taste. There's actually a lot more than we can do, but I think that's just to give you guys a little bit of a taste. It's not, the idea is not to show you guys, is to become a lesson of it. Something new, is more than anything just to show you guys a little bit of it. And I know that I didn't go in detail on it, but that is not the purpose. It's just to show you guys that there's what you could potentially study in the future, which is deep neural networks. Okay, what we wanted to do for this class is actually to study the other machine learning algorithms, which we did, and then not specifically the deep learning, because that's by itself way more complicated. It would take probably a whole year, 2 semesters to be able to teach in an advanced course. Okay, so we'll stop there.